In this video, I'm going to show you how to use the NBM, which is the National Blend of Models, which is really just a blend of models or a conglomerate of models that are put together in a particular way in order to create a better weather forecast. And I'm going to show you how to use the text bulletins to forecast for particular locations across the United States. So there are different versions of the NBM, which can go from an hourly format to a super extended range, and the hourly format goes out over the next 24 hours, whereas the super extended range goes out all the way to 264 hours, or a little bit over a 2-week period. So I'm going to show you how to use all of these and what these different text products can do for you in regards to creating a weather forecast. So in this video, I'm going to just keep it relatively short, or as short as possible, and I'm really just going to show you how to use the NBS and the NBH in order to create a weather forecast. So the NBS, this is more of a traditional style text product where everything is plotted in a 3-hourly interval. So you notice that there's a lot going on in this chart. So I'm going to basically break it down for you line by line. But if you get confused, don't worry, because at the very bottom, which I'll provide the link for this page, but it shows you what the elements are and what they mean. But I'm just going to go through it quickly in this video. So here in this example, this is for KBWI, which is Baltimore Washington International Airport in Anne Arundel, Maryland. Now, this forecast was ran on the 29th of 2019, and it was ran at 7 UTC. So the second line here, the DT, that would be the date. So here would be May 29th, here would be May 30th, May 31st, and then as you can see, it kind of overlaps into June 1st. The UTC, this would be Zulu time, or Greenwich Mean Time, or Universal Coordination Time. They're all the same, they just have different names. So 12 UTC, if it's May, and since this is on the East Coast, 12 UTC would be 8 o'clock in the morning. 3 hours later, it would be 11 a.m. 3 hours later, it would be 2 p.m. in the afternoon, 5 p.m., and then 8 p.m. Remember, 8 p.m., our local time is 0Z Greenwich Mean Time. That means it's midnight in Greenwich, England, and that starts the new day, which in this example is May 30th. So that's the hardest part. So that's why you really have to understand what Zulu time is and where you are. If you're still having trouble with Zulu time, please refer back to the How to Read Zulu Time video. The FHR, this is, you don't necessarily need to worry about this. This would be the forecast hour. As you can see, it goes out to about 70 hours or so. Now the X/N line, this would be the highs and the lows of the day. Here you can see that the high, right, is obtained by 8 p.m. on May 29th, because even though this is 0Z and it starts the new day technically, because this is based off of Greenwich, England, Greenwich Mean Time, our local time is 8 p.m. in this example. If it was the winter months, then this would be 7 p.m. But since we're in daylight savings time, the high of the day would have been achieved at some point in the afternoon, but it would have been achieved by 8 o'clock in the evening, because the sun will have already set by then and will have already reached the maximum temperature of the day. Same thing for the low. The low on the 30th would be achieved by 12 Zulu, or 8 o'clock in the morning, when the sun starts to come up. Now we know that the sun starts to come up earlier than that, but at least the low will have been achieved by 8 o'clock in the morning. So as you can see, the high for May 30th is projected to be 87 degrees, and the low on the 31st would be 66 degrees, the high in the 31st would be 81 degrees, and so on and so forth. So that's how you use the X/N line. This would give you your highs and lows for the day. Now the TMP, this would be the temperature plot in 3-hourly intervals. So here you can see that between 2 o'clock in the afternoon and 5 p.m. in the afternoon, we know that at some point this is going to be the highest temperature of the day, somewhere in that 3-hourly time span. But here you notice that the two numbers are 90 and 88, but the high is 92. That's just because this 90, the model is saying that we're going to achieve 90 degrees by 2 p.m. in the afternoon, and it's going to be 88 degrees by 5 p.m. in the afternoon. But either at 3 or 4 o'clock in the afternoon, the temperature is actually going to jump up 2 degrees to 92. That's why the x/n, the high and the low column, is different than the temperature column. That's why it's a little bit different. Now dPT, this would be dew point temperature. These are all in degrees Fahrenheit, same thing as temperature. Now sky, this would be the percentage of sky cover in 3 hourly time chunks. So here you can see in the early morning hours at 12Z, the sky cover over Baltimore, Maryland is only 15%, but then it jumps up to 44% by 11 o'clock in the afternoon, and then it goes down a little bit to 38%, and then it looks like it jumps up a little bit to about 52%, 63%, 68%, and then it decreases from there. So what does that mean in terms of sky category? Well, if it's 15%, that's fairly clear, right? Maybe just a few clouds in the sky. But at 52%, that would be something like partly cloudy or partly sunny, something like that, where half the sky is covered. When you get into the 60s, this would be mostly cloudy, so more of an increase in cloud cover, and so on and so forth, right? Mostly cloudy, 78%, okay? Or you could even say overcast. When you start getting to 80%, it's mostly cloudy. Maybe there's a few breaks of sun, okay? You don't have to get too caught up with that. Now, wind direction, WDR, this would be what the direction of the wind and where it's coming from. So you have to look at these numbers and you have to put a zero, an imaginary zero at the end. So as this reads 23, this is really going to be 230, 250, 240, and so on and so forth. And what does that mean? Well, when we look at wind direction and when we report wind direction, we either report it from a northerly or a northeasterly or easterly or a westerly direction. So that means that if I'm reporting the wind coming from the south-southeast, that means my wind is blowing from the south-southeast and it's going towards the northwest, but the wind is coming from the southeast. So that's how the wind gets reported. But we use degrees in a unit circle like this. So if the wind is coming from the southeast, that means that my wind would be 150 degrees, or coming from the direction of 150 degrees, which would be a southeasterly wind. So when we look back at the example, here I see 23, 25, 24, 26. Remember, so this, I have to add a zero here. So this would be 230 degrees, 250 degrees, 240 degrees, so on and so forth. So when I go back to my unit circle, I notice that the wind is coming from 230, 240, something like this, and that means that my wind is coming from the southwesterly direction. And basically, in this example, it comes from a southwesterly direction for most of the day, going into the overnight hours, and then it looks like it basically flips a little bit to the west, right? 270, go back to my unit circle, 270 would be a westerly wind direction. And then it kind of goes a little bit more northwesterly as we go throughout the day, because here would be 330, 320, 310, right? So the wind is coming from a more northwesterly direction, as you can see here. Now, when the wind says 0, 0, that means that the wind is calm, because calm wind doesn't have any direction, and the wind speed is usually less than 5 knots, more or less. Here would be the wind speed. This would be reported in knots, and knots is very similar to miles per hour. So if I was a forecaster here and I was looking at the winds, especially for the afternoon, I would say the winds are right around 6 knots, but as meteorologists, we usually put a range on things, and we say, okay, well, 6 knots could be anywhere between 6 and maybe 10 knots. We'll go on a higher end. You always want to add a few miles per hour to whatever this is saying, especially when you look at the next column, which is wind gusts. The gusts are gusting to about 18. So if I said, sustained winds of 6 to 12 knots with gusts up to 18 knots, that would be very easy and relatively correct to say, because here, if I'm looking at, 6 knots I can add a few degrees, maybe say 10 knots, and then if the wind is gusting to 18 knots, that relatively makes meteorological sense. So that would be the wind speed and wind direction and wind gusts. Now the P6 and the P12, this would be the probability of precipitation in a 6-hourly chunk or a 12-hourly chunk, depending on what you wanted to look at. So here you can see that these are all percentages. This is 5%, 48%, 26%, 57%, 26%, and so on and so forth. So when you want to know if it's going to rain today, the first thing you say, okay, is it going to rain today? And if someone says yes, or a meteorologist says yes, then you want to know, well, what time is it going to rain and how much is it going to rain? That's a very valid question. So when you look at the probability of rain in a 6-hourly time block, to me that's a little bit more accurate than looking at the probability of rain in a 12-hour time block. Not that the probability in a 12-hour time block is bad, but that's like saying, okay, at some point today between 8 o'clock in the morning and 8 p.m. in the evening, there's a 57% chance that it's going to rain. Okay, well, that doesn't give you a lot. That just says, okay, at some point today, there's a chance of rain. But when? Imagine you had an outdoor event that you were going to, and you really wanted to know what time or a more specific time frame that it would rain. So at some point today, we're expecting rain. That's not very specific, right? But if I look a little bit deeper here I notice that between 12 and 18 Zulu, right, or between 8 o'clock in the morning and 2 o'clock in the afternoon, I only have a 5% chance of rain. Okay, so it looks like the morning hours into the early afternoon hours, well, that looks pretty rain-free. That looks relatively dry. But from 2 o'clock in the afternoon through 8 o'clock in the evening, my probability jumps from 5% to 48%. Okay, so it looks like between 2 o'clock in the afternoon, sometime between 2 o'clock in the afternoon to 8 o'clock in the evening, we have a 48% chance of rain. So that's a lot better of a time interval that you could say to somebody, okay, if we do get rain, there's only a 48% chance, which is kind of a coin flip, right? It could happen, it could not. So at 48% chance between 2 and 8 p.m., we might get some rain. Well, that is a lot better than saying, well, at some point today, there's going to be rain. Well, at least you're giving a definitive time block. Now, how much is it going to rain? That would be the next question somebody would ask. So you could look at the Q6 and the Q12. This would be quantitative precipitation, or how much rain actually fell in a 6-hour or 12-hour time block. Now, the numbers here, you have to divide them by 100. If you look at the Q6, 6-hour quantitative precipitation, 1/100th of an inch. So you have to divide it by 100, whatever these numbers are. So if I divide this 2 by 100, that is 0.02. So at some point in the afternoon, right, I have a 48% chance between the hours of 2 in the afternoon and 8 p.m. in the evening, I have a 48% chance of rain. If it does rain, this model is saying, well, I'm only going to get 0.02 or 2/100ths of an inch of rain, which is really not that much, especially when you divide 0.02 or 2/100ths of an inch over a 6-hourly time block. That's not that much rain. So if you were forecasting for somebody and they had an outdoor event, or they wanted to know if there was a chance of rain and when and how much, you could literally say, well, there's only, there's a chance of rain in the afternoon through the early evening hours, but if it does rain, it's not going to be much because it's only forecasted to be 2/100ths of an inch of rain. So that's how you use the probability of rain and the QPF in order to determine how much rain is going to fall and what the chance of rain is in a 6-hourly timestamp. Now here we know that precipitation might not necessarily always be rain. It might be snow, it might be sleet, it might be ice. And that's what the probabilities are. The PZR, that would be freezing rain. PSN would be probability of snow. And the PPL, that would be the probability of ice pellets. PL for pellets. And then the PR would be probability of rain. So it says here, if any precipitation does fall, it's going to fall as rain. And that makes sense because this is in May, right? Going into early June in the mid-Atlantic. So with a temperature of 92, it's not going to snow one bit. But if it was, here would be how much snow fell in a 6-hourly timestamp, and this would be how much ice fell in a 6-hourly timestamp, okay? So you don't necessarily have to worry about these too much, but if you were forecasting for a location at a time where there was going to be snow, you could just take this number, divide it by 10, as it says in the directions here, and it would give you how much snow has fallen in that 6-hourly timestamp. So that's how you use the MBS in a 3-hourly, but what happens if you want to get a little bit more definitive, you want to get a little bit more accurate with your weather forecasts, and if it's in a 24-hour period, well then you can use the MBH. So the MBH, we're going to use the same example, it's the same timestamp, same location, and we're going to focus here on probability of precipitation, how much precipitation is going to fall. So remember in the previous example, I said some point between 2 o'clock in the afternoon and 8 p.m. was our best chance for rain. And here you can see that's basically the same thing in this probability of 6-hourly precipitation. But the probability of precipitation in an hourly format, here you can see it's a lot more definitive. So if you look at 18Z, the probability of rain at 18Z is only 5%. The probability of rain at 19Z, that's 3 o'clock in the afternoon, that would only be 10%. But the probability of rain or precipitation at 20 Zulu, okay, 4 o'clock in the afternoon, jumps up to 54%. And then it stays elevated in the upper 50s and then starts to taper off at 23 Zulu, which would be 7 o'clock in the evening, and definitely by 0Z, which would be 8 o'clock in the evening. Here you can see that the probability is really decreased down to 18%. So here you can see that if you were to make a forecast, you could get a little bit more accurate in what time it's actually going to rain. So here you could see it looks like the best chance, according to the hourlies, was between 3 o'clock in the afternoon and 7 o'clock in the afternoon. So a 4-hour interval is more accurate than just a 6-hour interval, because now you're saying, well, it looks like anywhere between 2 and 8 p.m. it's going to rain, but you have a better chance of seeing rain really between 3 and 7 p.m. And how much rain are you going to get? Well, you just add up how much rain you're going to get in these 1-hourly intervals. So here would be a 2, and this would be a 1. So when you add those up, 2 plus 1 is 3. But remember, this is quantitative precipitation, so I have to divide that number by 100, and that would mean that between that 4-hour interval, I'm only getting 0.03 inches of liquid rainfall, or liquid equivalent, right? Because this could be snow, but in this example, it's just rain. So 0.03 in a 4-hourly timestamp. That means really just a light passing shower at the very best, because 0.03 over a 4-hour interval is not that much rain. So that's how you can use the MBH and you can use the MBS in order to create a weather forecast. Now, if you get lost in what all these codes mean and how to use them, the key is right here. So all you have to do is just read what the key is and then apply the same concepts that I just went over in order to create a weather forecast.